Scene 1. Introduction to Rational Numbers. The video opens with an introduction to basic mathematical concepts and their daily applications. The narrator explains that among the many fascinating concepts in mathematics, rational numbers play a crucial role in both academic understanding and real-world application. Scene 2. Defining rational numbers. The video transitions to defining what a rational number is. The narrator states, a rational number is any number that can be expressed as the quotient or fraction p/q of two integers, where p is the numerator and q is the non-zero denominator. Visuals of different fractions, such as 1/2, -3/4, and 5/1 are shown on screen. Scene 3. Properties of rational numbers. The narrator explains that rational numbers have a specific set of properties. They can be positive, negative, or zero. A rational number's decimal representation either terminates or repeats. The video demonstrates this with numbers like 0.75, a terminating decimal, and 0.333, a repeating decimal. Scene 4. Identifying rational numbers. The narrator guides viewers through the process of identifying rational numbers. Several examples are presented, and the narrator asks the viewers to determine if certain numbers, like -11 for 0.25 or the square root of 2, are rational. Correct answers are revealed with explanations. Scene 5. Operations with rational numbers. The video explores the arithmetic operations that can be performed on rational numbers. It showcases addition, subtraction, multiplication, and division using fraction-based examples. The narrator emphasizes the importance of finding a common denominator for addition and subtraction. Scene 6. Real-world applications. A segment of the video deals with real-world applications where rational numbers are used. Examples include sharing recipes, calculating distances, and financial transactions. This highlights the relevance and necessity of understanding rational numbers beyond classroom learning. Scene 7. Advanced concepts and challenges. The narrator introduces advanced concepts related to rational numbers, such as rational approximations and the concept of irrational numbers, to contrast and deepen the understanding. A few challenges are presented to viewers to test their grasp of the topic, with solutions provided at the end. Scene 8. Conclusion and summary. The video concludes with a recap of the key concepts covered, emphasizing the importance of rational numbers in various fields of math and everyday life. Viewers are encouraged to practice more with the given references to enhance their understanding. The end credits roll, acknowledging contributors and suggesting further reading materials and online resources for learners interested in diving deeper into the world of rational numbers. Introduction. The subject of rational numbers forms an integral part of mathematics. A rational number, in its most basic form, refers to any number that can be expressed as a quotient or fraction p/q of two integers, where p is the numerator and q, not zero, is the denominator. Scene 1. Basic concept of rational numbers. Start with the definition of rational numbers to set the foundation. Include examples to illustrate how any number in the form of a fraction, such as 1/2, -3/4, 5, or 0.75, constitutes a rational number. Scene 2. Operations involving rational numbers. Detail the four basic arithmetic operations: addition, subtraction, multiplication, and division, as applied to rational numbers. Addition. To add fractions, first ensure they have a common denominator. For example, to add 1/2 and 1/3, find the least common denominator, which is 6. Convert 1/2 to 3/6 and 1/3 to 2/6, then add them to get 5/6. Subtraction. Similar to addition, ensure fractions have a common denominator before subtracting. Multiplication. Multiply the numerators together and the denominators together. For example, 1/2*1/3 equals 1/6. Division. Invert the divisor and multiply. For example, 1/2 divided by 1/3 is the same as 1/2*3/1, which equals 3/2. Problems. 1. Add 1/4 and 1/6. Solution. The least common denominator is 12. Convert 1/4 to 3/12 and 1/6 to 2/12, then add them to get 5/12. 2. Subtract 3/8 from 5/8. Solution. Since the denominators are the same, subtract the numerators. 5 minus 3 is equal to 2, so the answer is 2/8, which simplifies to 1/4. 3. Multiply 2/5 by March 7th. Solution. Multiply the numerators. 2 times 3 is equal to 6, and the denominators. 5 times 7 is equal to 35, so the answer is 6/35. 4. Divide 4/9 by February 3rd. Solution. Invert 2/3 to get 3/2 and multiply. 4/9*3/2 equals 12/18, which simplifies to 2/3. Scene 3. Comparing rational numbers. Explain the process of comparing two or more rational numbers. Discuss techniques such as converting fractions to have the same denominators, cross-multiplication, or converting them to decimal form for comparisons. Demonstrate with examples showing the rearrangement of a set of rational numbers in ascending or descending order. Scene 4. Representing rational numbers on number line. Highlight how rational numbers are represented on a number line. Through visual aids, show step-by-step how fractions like 3/4 or -5/2 are plotted relative to integers. Scene 5. Complex problem solving. Move to more complex problems, such as finding unknowns in equations involving rational numbers or solving word problems that require a specific understanding of rational numbers. Scene 6. Real-world application problems. Discuss real-world scenarios where rational numbers are essential. Problems can involve financial calculations, such as calculating interests, proportions in recipes, or determining ratios in project plans. Conclusion. Summarize the key points covered in the video: definition, basic operations, comparison, representation, and application of rational numbers in real-life scenarios. Encourage the viewer to solve practice problems to reinforce understanding.